So welcome, everybody. It is super exciting to see everyone over here, especially after nap. No one decided to take a siesta and join us, so welcome. Thank you very much. Let me start by introducing myself and my co-presenters today. My name is Amruta Gulanikar. I am a product manager on the Google Compute Engine team, and I represent the team that is responsible for making sure Windows workloads work great on GCE. With me today, I have Ben and Michael. Ben is the TL for Google's M&A infrastructure service team, and Michael is a senior director at Apprenda, and he also leads the special interest group that is tasked with bringing Windows containers to Kubernetes. So welcome, everyone, and let's get this show started. So here are some cool headshots of us in case our live is good. So let's have a quick overview of what we're going to be talking about today. So we're going to start with sharing why customers want to choose GCP for bringing their Windows workloads, what are some of the recent launches, and talk a little bit about our Windows Partner Program. I'm then going to dive into some of the key platform-specific improvements that we have launched, some best practices, and then Ben is going to come up on stage and showcase how his team uses some of those to manage the Windows IT infrastructure for Alphabet companies and acquisitions on Google Cloud. Last but not the least, we're going to talk about how you can use containers to deploy and scale your Windows-based applications. And Michael is going to come and present all the great work that the SIG has been doing to get Windows container support over to Kubernetes. Before we go into that, I really want to iterate on our mission. As you saw, Brian Stevens, the VP at Google Cloud, say that Windows is a priority for us. And our team truly believes that our mission is to deliver the best performance, security, reliability for Windows users on our platform. And we've been at work. Over the last year, we have over a dozen Windows-specific launches. And you can see some of them over here. Our journey with Windows started in 2014 when we released the first beta for Windows Server support. In 2015, we GA'd Windows Server 2008 and 2012. And as you can see, we've added a ton more capabilities in the last year. SQL Server, VSS integrated PD snapshots, cloud tools for Visual Studios and PowerShell, and SQL HA clustering support. So we're going to go into a bunch of these in detail. But along with all this great platform support, we're also building an ecosystem. We have a great set of Windows partners who are not only experts in Windows, but also on GCP that can help you migrate your Windows workloads from wherever they are, on-prem, colo, over to GCP. So please, urge you, we announced this today. Brian, you probably heard Brian in his keynote. I urge you to go to cloud.google.com/windows/partners and check out our great partners. So now let's answer this question. Why bring Windows workloads to GCP? I was talking to a couple of folks, and they were like, yeah, we would like to hear more about that, so let's just dive in. The first thing is Google's infrastructure. When you bring your Windows workloads to GCP, you get all the inherent unique capabilities of our infrastructure. Your traffic will never leave Google's privately owned fiber network, even when you go between data centers. What this means for you is that you get super low latencies, a consistent throughput, fast VM boot up times, and autoscaling that just works. And this is one of main reasons why we have a ton of gaming companies and enterprise companies who really love running Windows workloads on GCP. For folks who like transparent maintenance, we have live migration. Your VMs can move from different hosts without any impact to your workload. And if you're really interested in running SQL Server workloads on us, we give 40K IOPS on our persistent disk storage at no extra cost. Price. Price is always very important. We really strive to give a very simple and intuitive pricing model. If you see our Windows pricing, it's 4 cents per core per hour for all your VM types. So if you want to understand what your cost is going to be, it's a very simple and easy way to calculate it, no hidden costs. Most Windows workloads run 24/7, and at the end of it, you get a sustained use discount, which gives you up to a 30% lower cost at the end of the month, just by running your workloads steady state. We announced the committed use discount program today. If you want to look at longer-term commitments for your steady-state workloads, we have that option too. One of the biggest things that customers love when they come to our platform is the flexibility of custom VMs. Custom VMs is a great example. You don't really need to be locked into any predefined VM, right? So think about if you're running SQL Server. You don't need to run it on a 16-core VM when you just need 10 vCPUs. And that is really powerful, especially for Windows, because not only are you getting the machine shape that you exactly want, but you no longer have to pay license cost for those extra vCPUs, as licensing is tied to cores. So as we make progress in getting machines which have higher memory with lower CPUs, you can take full advantage of that. Now, I talked about a bunch of these which were very across the platform. Let's talk about some Windows-specific reasons to bring your workloads to GCP. We support SQL Server and Windows Server images. You could run SQL Server even before. But now we have introduced support for SQL Server always-on availability groups. So you can have the same HA configuration that you had on-premise on GCE window VMs today. We have things like volume shadow copy service, which is very critical for enterprise workloads who want to back up their data disks in a reliable manner without affecting their workload. We have tools, the interactive serial port access. You have tools for Visual Studios, PowerShells. All the .NET developers in the room have ample support to run, to write their ASP.NET or ASP.NET Core applications on our platform. In the same spirit of flexibility, customers ask me, I have existing license for SQL Server. Can I bring them on? Yes. You can bring on your existing EAs with software assurance over to GCP. And all these features and wide range of Windows and SQL Server images that I mentioned are available to you in the free trial. So if you're new to the platform, you want to give it a try, register in our free trial program, and you can try all of these for $300 credits, 12 months. So hopefully these are some good reasons, and our customers really value some of these when they bring their applications to us. Now let's talk about bringing your VMs to GCE. A lot of customers have existing VMs on-premise that they want to bring over to GCE. And we have a great partnership with Cloud Endure, which will migrate your Windows VMs to GCE at no charge. Could that be better? We recommend that you go into our UI on our Cloud Console. Right next to creating an instance, you'll have a nice button there which says Import VM. And you will be able to follow a very simple process to bring over your Windows VMs. We have a full range of planning and implementation partners, so really encourage you to go check out cloud.google/migrate for details or come up and ask me questions. So let's say we don't want to migrate a VM. I just want to spin up a new VM. What do we support? We have a really long list of Windows Server images and SQL Server images that we support. I'd like to point out that we released support for Windows Server 2016 last year, and we did that within a week of Microsoft GAing their new OS version. And I like to point that out because this really shows that we are committed to making sure that anything that is the latest technology on Windows is available on our platform too. And it also points to the great relationship that we have with Microsoft in helping us doing this in a really timely manner. We have support for Core and Nano coming soon. And a lot of customers asked us for SQL Server images. So these are images with the licensing including. You don't need a SPLA. You don't need to buy licensing anywhere. It is pay-as-you-go per minute billing. Now, when we talk about SQL Server, the very next question is, do you have HA support? And as I mentioned, yes, we do have support for high availability using always-on availability groups. Now, this is very similar to what you would probably have on-premise. You can deploy a multi-node SQL cluster, set up your availability group listener, join it to your AD domain, and have it work just like you had it working on-premise. Yesterday, we did a great demonstration of this and demonstrated failover. If you want to go and see that talk, please look at the recording for running SQL servers. But one thing I'd really like to point out is we have detailed guides and scripts. But setting up SQL HA is not an easy process. Anyone has set up a SQL HA before? No, a few of you. So you know that this is a multi-step process. A lot of things can go wrong. And just to get a proof of concept takes a bunch of time. So what we've done is we've got a Cloud Launcher template. In one click, you can set up a multi-node cluster for you in your project. And this is great if you want to do a quick POC, you want to test failover, just see how it works on the platform. So really encourage you to go and try that out. We talked about VSS. The reason I want to really stress on VSS is what you get with VSS is application-consistent backups for your data disks on SQL Server without having to turn out your VM. Now, this is a service that is supported by Windows Server, and applications like SQL Server have great native support for VSS writers. And this is really a great, unique capability on our platform that will allow you to have more reliable backup and disaster recovery solutions. So now we've set up all our VMs. We've deployed a bunch of HA configurations. Simple question, how do I access my VMs? So you can access your VMs using RDP. By default, that is open. But we've also supported WinRM for all our Windows and SQL Server images. So you can really take advantage of running HTTPS, WinRM over HTTPS, and accessing your VMs. I also talked a little bit about tools, like once your instance is set up, how do you exactly know that it is set up correctly? So let me show you some of the cool things you can do with the interactive serial port access control. I'm going to call this Icepack because interactive serial port access control is a real tongue twister. So you'll see me saying Icepack a bunch. So that's what it is. OK, so switching over to my demo machine. As you can see, I've just spun up a simple Windows instance. This is based on the Windows Server 2016 image. And I'm going to try to see if this instance was set up correctly. So I'm going to click on it. And I'm going to scroll down. And I see this view serial port. And I'm going to click on it. And it will show me that the instance was set up correctly. I have RDP set up correctly. I have WinRM configured. I'm good to go. Now let's see if I can really RDP into this machine. It's taking some time, longer than expected. Oh, this seems to be an error. So it says that the remote access server is not enabled or the machine's not running. So I can definitely see that the machine's running. I saw that RDP was configured on my instance. So what do I do now? So we have Icepack. So I'm going to connect to the serial port really quickly. And just to save some time while this SSH is in, and I'll switch back, I actually already logged in. So let's see if it reconnects. All right. I'm going to punch in my password. And there you go. If you are a Windows sysadmin, you'll recognize this console. You didn't have to leave the web browser, and you have access to this. Now, I can run things like, hey, is this, did it also lose internet connectivity? Is this actually connected? So I'm going to see. Yeah, it seems to be connected to the internet fine. Most of the problems that we see with RDP not working is the Windows firewall. Either the rules are not enabled or it's just not on. So let's just do a quick check on what the Windows firewall status is. Oh, the Windows firewall is off. No wonder RDP is not working. So let's go and restart that. I think I made a. Let's type that again. Apparently, I can't type today. There you go. So the Windows firewall is started. Now let me see if that really fixed that issue. So let me go up and really from the browser, try to RDP in. Super convenient. There you go. Someone messed up the Windows firewall. That was me. But this was just for demo purposes. So switching back to slides. So you can see that we've really worked hard on making sure that certain difficult problems are made really super easy for you, and that's the advantage of running Windows workloads on us. So we have said quick demo. So now you've deployed these machines, but you're not going to do this one machine at a time. You want to deploy this in a scalable fashion. And we have some great tools with startup and shutdown scripts that allow you to do this. So I'm going to have Ben up on stage to demonstrate how their team takes a code-driven approach to manage IT infrastructure for alphabet companies who are running Windows on Google Cloud. Ben?
Thanks, Amruta. Hi, my name is Ben Miller. I work for Google's Mergers and Acquisitions Infrastructure Services team, and I'm here to talk to you about our project Gecko, which is currently managing Windows instances in Google Cloud. So, what is Gecko? Gecko is code-driven, managed IT infrastructure for Alphabet entities and acquisitions. Alphabet entities are separate companies, and so they often don't have access to Google corporate IT infrastructure. Although Gecko needs customer environments, although each Gecko customer needs an independent IT infrastructure for a variety of reasons, we need a scalable solution for management of those environments. We strive to achieve this through services, policies, and standards that we can define in code and deploy through automation. Our customers don't want to spend time and energy reinventing the wheels themselves, so they order their wheels from us. Gecko environments contain Linux and Windows workstations, instances, and use Active Directory for directory services. We provide cloud-hosted infrastructure services to Gecko customers. Services like Active Directory, network infrastructure and security services, central file sharing, disaster recovery. Our goal is to scalably manage infrastructure services in per-customer deployments, following shared best practices and using a shared management framework. Gecko achieves this in part by automating the deployment and configuration of per-customer GCE environments. Here's a very high-level example of what one might look like. A typical Gecko environment is comprised of a customer-specific GCE project connected to the customer's on-site network via Cloud VPN. Typically, the project will span multiple geographic regions for fault tolerance. Each Gecko service is expressed in code that defines well-understood and well-tested behaviors. This functional code does not change from one customer to the next. Each Gecko customer environment is defined in a customer-specific repository, which contains structured configuration files, certificates, and other things that are specific to that customer. This repository defines all aspects of the customer environment, from host-level configuration to configuration parameters that specialize the behavior of each Gecko service. This repository links back to the main Gecko source, where all of the functional code is maintained. Now, this link can point to the most recent version of the Gecko code, or it can be pinned to a specific version. This simplifies maintenance and upgrades as new versions of Gecko and Gecko services can be rolled out over time. The separation between functional code in Gecko and customer configuration can be seen from the beginning during the instance build process. Gecko instances are built using a function that we define in our Gecko PowerShell module. The instance can be built simply by referring to its name, and all of the necessary details to build that instance will be extracted from the customer's configuration. Now let me focus for a moment on how Google Compute Engine has simplified Windows instance building and configuration. First, let me call out the Google Cloud PowerShell module. The folks in Google Cloud have provided us with some fantastic tools to manage GCE resources using PowerShell. I'll be using commandlets from this module to demonstrate how we build Windows infrastructure. Now let's talk about the build image. The Windows Server image provided by GCE is kept up to date for you with the latest hotfixes, so you don't have to maintain that yourself. When you boot a Windows image for the first time in Google Cloud, it boots into the sysprep specialized configuration pass. And for those of you who are less familiar with sysprep, what this means is that the first time a Windows instance is spun up in your project, it runs a series of specialization tasks that finalize the Windows install. GCE gives you several options to inject custom scripts into this process without rebuilding the image. And one of these options is to leverage the GCE metadata service to store an instance-specific script that will be executed during the specialized pass, and that's what we do. Note that this is in addition to the startup and shutdown scripts that you can also define in metadata that will run at each startup and shutdown of the instance. Gecko uses sysprep specialize as an opportunity to inject a very simple script to bootstrap the Gecko build and configuration process. Okay, can we switch to the demo computer, please? Okay, the code that you will see here is representative of the process that the Gecko project employs, but it is, of course, not exactly the same code that we use in production. Here we have a short script that will be used to build a Windows instance. What we've done here is reference the current GCE Windows Server 2016 core image, populate the appropriate metadata with our Bootstrap script, and call add GCE instance to create the new machine. This commandlet is part of the Google Cloud PowerShell module. As you can see, you can also add a startup and/or shutdown script at the same time when you are creating the instance. So while this runs, let me show you how instance metadata becomes a sysprep specialized script. Using the getGCE instance commandlet, you can retrieve an object that describes all of the attributes of your GCE instances. Now here I've drilled down specifically just to list the instance metadata. You can see that the startup, shutdown, and sysprep specialized keys have been populated with the values we provided when the instance was first created. And when a Windows instance is first created, the GCE agent on that machine looks for the sysprep specialized key in the GCP metadata service, and if it exists, it executes it. This is a really low-friction way of customizing your Windows instance builds. As the script executes, its output is mirrored to the instance's serial port. You already saw some of that in Amruta's demonstration, but I want to show you how this works in PowerShell. You can observe the serial output of your GCP instances by using the Cloud Console or by using the getGCE instance commandlet. You can see low-level output of the instance boot process, as well as other messages that are logged by the GCE agent. If I do a little bit of quick filtering, we should see just the output of the scripts that we defined in metadata. The output is truncated somewhat, but you can see what I've done there. As the script executes, oh, excuse me, one more slide, there we go. Okay, let's go back to the slides, please. So to recap, using Google Cloud PowerShell, we were able to reference a pre-built Windows Server core image, define startup, shutdown, and sysprep specialized scripts, and create a GCE instance. We were also able to monitor the progress of the instance's build using serial output. We did all of this from within PowerShell. Now, for Gecko, now that we have built an instance, how will it be configured and managed? In a nutshell, Gecko uses customer configuration files to drive PowerShell desired state configuration. How does this work? Well, each Gecko environment has a configuration master. In DSC terms, this is called a pull server. The config master iterates over the list of all Gecko instances defined in the customer config. Based on the roles and services associated with each instance, templates are merged together to construct the full configuration for the instance. Within each configuration template are DSC resources, whose attributes are populated using properties that are stored also in the customer configuration file. The output of this process is a compiled DSC configuration for each instance, which the pull server will host. And on a schedule, managed instances will pull their new configuration and apply them. They will report back to the config master with data on what changes were made and whether or not the configuration was applied successfully. Now, this is not a one-time operation. Managed instances will continually reevaluate their configuration and ensure that the desired configuration is applied. So our instances have been built and configured. How do we make changes to a customer environment? Our management pipeline is driven by open source projects. We use Gerrit for Git-based code review and Jenkins for continuous integration. Gecko strives to be a management framework with strong accountability for changes. So how do we achieve this? First, a Gecko admin submits a change for review. Now, this does not alter the customer environment, but it's a proposed change. This change could be anything from a new DNS record to a change to group policy to firewall rules, just to name a few examples. Now, this proposed change needs approval from two sources. First, our Jenkins instance will automatically run unit and integration tests. And second, another member of the Gecko admin team has to review the commit and provide final approval. Now finally, once all this is done, the configuration master will recompile instance configurations based on the change, and the Gecko instances will pick up those changes. Now, this management pipeline is the core of Gecko. But why? Why did we take this approach to systems administration instead of managing things in a more traditional fashion? By defining our architecture in code and config, we can have strong assurance that the infrastructure is built and operates as designed. When we implement best practices, we are able to implement across all of our customers. And by standardizing the services that we deploy and the way in which we deploy them, we're able to manage many customer environments using the same set of management tools and procedures. All of this allows us to scale support for additional customers without having to also linearly scale the size of our team. But why do we choose to build Gecko on GCE? Well, first of all, we take a lot of value from GCE's specific support for Windows as a platform. Custom instance sizing and simple hosted Windows licensing makes it easy for us to predict and invoice costs per customer. Building Windows VMs on GCE is really fast and simple to automate. And Google Cloud PowerShell is a huge win for us, allowing us to automate GCE using the same management framework that we use to manage our Windows infrastructure. Now, finally, as a customer of Google Cloud, the single biggest win is the performance, stability, and security of GCP. It allows our team to focus on just those challenges that are ours to solve. Now, let me hand the time back to Amruta, who's going to talk about container support for Windows workloads.
Thank you, Ben. So you saw a great demonstration of how you can configure Windows infrastructure on GCE. The question I often get from customers more recently is, how do you deploy your Windows-based applications using containers? And the answer is there are many different paths that you can take on GCP. You can stand up a Windows Server VM, Windows Server 2016, which is the first version to support Docker and Windows Server containers, and run your Windows containers on that. We also have support for Nano Server, which is coming soon, which will have a much smaller footprint. You can choose to have ASP.NET Core apps and run them in either Windows Server containers or Linux containers. You have options when you want to manage orchestration of your containers, and you can either choose Kubernetes or Google Compute Engine. So today, if you have an ASP.NET Core app, you can run it on a Linux container on Google Container Engine. We are also contributing to the open source special interest group that I mentioned, which is tasked with bringing Windows containers support to Kubernetes. And if you want an even more managed solution, then we just launched support for ASP.NET Core on App Engine Flex or App Engine Flexible environments. So you can have multiple different options. Now, in order to demonstrate the great work that the open source community has been doing for Windows containers and Kubernetes, I'd like to call up Michael on stage to talk more about that.
Thank you, Amruta. Hi, everybody. So I'm here representing the special interest group for Windows Server containers from the Kubernetes community. So quick show of hands. How many of you guys have used Kubernetes so far, whether on-premise or in a cloud provider like Google Cloud? All right, a few of you guys. So one of the most important things is if you are using Kubernetes, it is one of the best tools out there to be able to operate, manage, deploy containers at scale. It really makes life simple. So if you are deploying containers today in traditional virtual machines or whether that's on-premise or in a cloud provider, it's hard to actually make sure what image are you using, control the workflow, whether that's a continuous integration or a continuous deployment system, and being able to scale those. With Kubernetes, you have a complete platform that manages the end-to-end lifecycle of your containers from the point where you define what application you want to run into the container, to defining the networking for it, being able to scale it to the hundreds or thousands of nodes, and then being able to version that and go from version 1 to version 2 and so on and so forth. So within the community, which has been running for a while now, one thing was lacking, and that was Windows Server support. So the SIG Windows team was tasked to go and bring Windows Server support to Kubernetes, and more importantly, to be able to run Windows Server containers. What that will give us is one of the best cross-platform heterogeneous cluster managers, and it would allow us to expand the types of applications that can run on Kubernetes. So before, you used to have applications that will run on the Linux operating system. By introducing Windows Server containers, now you can run IIS-based applications, you can run .NET Core applications, you can run Windows services, and any other application that can run on the Windows OS. So that's a tremendous amount of change introduced to Kubernetes now with the ability to run all these extra workloads. And all of our work here in the special interest group is really based on top of the work that Microsoft done to both introduce Windows Server containers to the operating system, as well as a lot of the networking enhancements that have been made. There's a few companies that I want to call out here that have been doing a lot of work in the group, and that's Apprenda, where I'm coming from. There's Cloudbase, Google, Microsoft, and Red Hat as well. All these guys are contributing to make this a reality. From a status perspective, we have alpha support in Kubernetes today, so you can go and download our binaries and try this out. And with the release of Kubernetes that will come towards the end of Q2 of this year, we'll go in beta. So let's take a look at the architecture really quickly. One of the things that we wanted to make sure is that we kept the simplicity of Kubernetes and Docker as it exists today. So on the left-hand side, you have the existing Docker architecture for Linux on Kubernetes. And you'll see that you have the Docker images, the engine, and then you have a shared kernel down at the bottom where you can have one or more containers running on top of the same container host. That's the compute unit that's running your ecosystem. And on the right side, when we started architecting things for the Windows side, it was very advantageous that Docker now runs on Windows Server. And it has a very similar model to the running Linux. So we maintain the parity of having the Docker images on the node. You have your Docker engine daemon, which is what we are talking to as Kubernetes, and then having one or more containers running on top of a shared kernel. I would like to point out that Windows Server supports two types of containers today. One of it is Windows Server containers, where you have a shared kernel, and it also supports Hyper-V containers, where you have kernel mode isolation as well. Right now, we have been predominantly working on Windows Server containers, but there's nothing that prevents us from supporting Hyper-V containers as well as we go towards beta. With the alpha support that we had, this is what our architecture looked like. So you have the physical internet coming up from the top, and then you have the kubelet and the kubeproxy, which are the two components of Kubernetes that kind of drive the core functionality. And then you have an abstraction called a pod, which is the lowest unit of deployment in Kubernetes that can contain one or more containers. Think of a pod as a microservice, for example, that can be implemented inside one or more containers. So with the alpha support, this is what it would look like. And we went ahead and completely rewrote the networking stack of Kubernetes for Windows Server containers as we march towards beta to eliminate completely the kubeproxy and use OVN and OVS as the networking backbone for their containers. This provided us a tremendous amount of advantages, and it allowed us, as we move towards the future, to support things like network overlays and be able to do a network namespace isolation for containers that spans both Windows and Linux. So imagine this. You'll be able to have a single application that has containers running on Linux and on Windows, both of them in a single network namespace, communicating with each other in a secure and scalable manner. So let's switch here to a demo and show you some of this work in real time. And what you're looking at here is the Google Cloud SDK shell. So all of our components here are running in Google Cloud. So I'm going to go ahead and create an SSH session to my Kubernetes master component. So I will go ahead and change the resolution here so you guys can see that fairly well. All right, so the first thing we're going to do is we're going to go ahead and run as administrator here. And I'm going to run kubectl. This is the command line interface of Kubernetes. And I'm going to go ahead and get all the nodes that we have in the system here. And notice that I have two nodes. I have a master component that's running on Linux, and it contains all of the core pieces to run Kubernetes. And then the second thing I have is I have a worker node that's running Windows Server that is able to host pods on Windows. So if I check if I have any pods here, you'll notice that I don't have any pods deployed right now, so there's no resources deployed in the system. To demonstrate here some of the capabilities of our node, let's go ahead and describe the Windows node. And notice that its architecture is AMD64. It's running the same kubelet and kubeproxy version that the rest of my Kubernetes environment is running. And it has the same type of details in terms of the CPU performance metrics, the memory metrics, and all the other details like labels that Kubernetes has. So if I run this command here now, I'll be able to show you the labels that are identifying each node in my system. So notice that my master component is running Linux with AMD64 architecture, and now I have my worker in Windows node that's running the Windows operating system, and it's labeled accordingly. And now this label is important because that's how we're going to select pods to be attached to that node. So when you're deploying containers in Kubernetes, you get to tell Kubernetes where would you like those to be deployed. Think of this as a simple deployment policy, and we'll use the labels that are identifying each one of our nodes. So, so let's get started here. Let's go ahead and deploy some containers. So the first containers I'm going to go ahead and deploy is the first tier of my application, and this is a Redis cache that will form the data part of my application. So my application is going to be a microservice that has three components: a Redis slave, a Redis master, as well as a guestbook Go application running, all of these components running on Windows, but there's nothing preventing me from running one of them on Linux if I so choose. So we went ahead and deployed the Redis master, so I can go ahead and run my pods command again, and now notice that I have a single instance of my Redis master running here. So if I run my command kubectl logs and point it to the Redis master, notice that we have Redis 3.0.504 running inside Windows. So let's go ahead and create the slave now that will communicate with the master pod to complete the second tier of our application. And one of the things I want to show you is what does that look like. So let's go ahead and and look at one of the Redis components here. So this is a deployment specification on Kubernetes. So the pod, that abstraction I mentioned earlier, is defined using a specification like this. So in this deployment specification, I'm indicating that my name is Redis slave, and I want to use this specific image from the Docker hub. It's called Redis slave 3.0 nano server. So it's using the nano server OS, and it's basically exposing port 6379 over TCP. And the last important thing here is the fact that the node selector is targeting Windows Server. So now that we did this, if we exit out of the component here and we run our get pods command again, notice now that I have two Redis slave containers, pods up and running, and they have a very distinct IP address for each one of them, and that's basically, and they're all running on Windows Server now. So if I go back and check the logs for my master, notice now that the master was able to communicate with the slave at port 6379, and that's the same port that I identified in my description, or telling it, go ahead and find each other using that port. So now we have two tiers of our application up and running. We have a Redis slave, we have a Redis master. They were able to find each other and communicate, and they're all running in Windows. So let's go ahead now and deploy the last piece of our application, which is a guestbook application written in Go. Notice now that we created a single instance of our guestbook application, and I can actually go ahead and connect to it. So I can run kubectl exec-it and provide the guestbook node here. And I'm going to run PowerShell. So now we have a PowerShell execution inside the container that's running our guestbook application. So I can run ipconfig here, and I get an IP address, and that's the IP address of my container. And I can even actually ping the outside world. You might not think this is much, but it took us a long time to be able to enable internet access inside a container using the OVN overlay network. So we had to introduce things like a gateway node and be able to route the traffic, create the correct interpod and inter-container connectivity. So even though this is simple and we all take internet access for granted, this was a lot of work to make that happen. So now we actually have our pods. We have the service as well, and 3 different sets of pods that are comprised this specific service. So let's go ahead and describe our service in Kubernetes. And there's a few details here about our service that were taken out of the specification. You have a guestbook application. It has an IP address. It has a couple of different ports that you can use to access it. And I can actually go ahead and run a curl command here against that application. I'm going to go ahead and change the IP address here. And notice that it returned back some data telling me, hey, you're on container 10.24.9.4. More importantly, I can switch over here to my Windows node. That is the Windows node, that's the worker node that's part of my cluster. And notice everything is running on GCP here. I can switch on this node, and I can open up a web browser and hit my guestbook application. And I can enter some data here. And I'm going to call it audience 1, 2, and 3. So if I go back to my script here and I run the curl command again, I'm getting back the data because I was able to query that application. So let's go ahead and scale it and see some of the advantages of Kubernetes. So I'm going to run a command here that essentially is instructing Kubernetes to increase the deployment of guestbook to a 3 replica count. So if I run my get pods command again, I get to see that guestbook now has 3 instances running. Now, all 3 instances are going to be load balanced by Kubernetes. So as a developer, I don't have to do anything extra. I can take advantage of the complete backbone of Kubernetes that will handle routing, load balancing, fault tolerance, high availability. And all I had to do was deploy my application, and all of those things are taken for granted, and they're available to me to use. So now I can go back to my web browser again, and as I refresh, I can see the endpoints changing sometimes. Now, there are sticky sessions happening in the web browser, so you might not be able to see this clearly. So I went ahead and wrote a script here that will invoke the URI for my application 20 times and print the contents. And notice here that every time we invoke it, the IP address sometimes changes because Kubernetes is basically load balancing the request to my application based on number of requests per second. So some of them are hitting the container IP.4, 192, actually I should have a third one here as well. So if we go up, we should be able to see the 187 IP address as well here. So those are the 3 IP addresses that are part of my pod that are available for load balancing for my application. And if we go back to guestbook here, if I click the environment variables, it is clearly evident here that I'm running on Windows. This is Windows Server containers. I'm able to see all the information about the Redis cache that is part of my application. And I can come back into the node and I can run Docker commands like Docker images and see the images that I was able to use for the deployment of my application on Docker PS and look at all the containers that were deployed by Kubernetes as part of my app. So Kubernetes handled everything from the deployment of my containers, the setting up of the networking backbone, the load balancing, as well as making sure that my containers are up and running and highly available. Let's go ahead and switch to the slides. So we showed you how Kubernetes and the community is bringing Windows Server support into the entire ecosystem. We're encouraging everybody, if you want to get involved or even try this work, go ahead and find us on Slack. You can also visit our GitHub page, and we'll encourage everybody that's passionate about Windows, passionate about orchestrators and cluster managers to come along, go ahead and get involved, try out our capabilities, or create a PR and introduce some of your own code into the mix. Thank you.
Wasn't that awesome? So we've taken you through this journey and kind of told you some of the capabilities of the platform, some reasons that will give you some really great advantages by bringing Windows workloads to us. We have tools to bring your traditional Windows workloads, and we have some great set of tools if you want to modernize your Windows workloads with Kubernetes support, with App Engine Flex, and so on and so forth. So we have a ton of resources at cloud.google.com/windows/SQL Server/.NET. So really encourage you to kind of go and do a deeper dives. And now we can open up for some questions. So I have up here, before we go into questions, some of the talks. Now, we were the last talk, so there were some 200 and 300 level deep dives, and our session sort of brought it all together to give you a quick summary. But please look at the recordings if you've missed any. And there's a Meter expert session going on right now. I think you'll probably have have an hour for that too, so please attend that too. So with that, hopefully we answered some of your questions, and if not, we're here. I'd like to call Michael, Ben up on stage, and also Fang, who is the TL for Windows, up on stage to take any of your questions.